Okay, it's recording now. So do you hear me? Yeah, just let me know whether you hear me. Okay, good. So yeah, this week we will continue the this lecture. We will continue the dynamic programming. Okay, so last last lecture, right? This Tuesday, yeah, we learned about the dynamic programming. So it's just like similar to the recursive function. The only difference is you have a memory to store the subproblem that you already calculate, so that you can save time, right? You don't need to recalculate the thing that you already calculated. Okay. So for the dynamic programming, it has many applications. Okay. For example, like I mentioned, like we have the longest common subsequence. If we have the two sequences, then we can find out what is the longest common subsequence. It's very important, for example, in the checking the DNA, right? You have the two DNA sequences, and then you need to find the common subsequence among two samples, so that you can identify the family relationship or somehow. Yeah. Also, some application. Then today we will use the dynamic programming for two applications. Okay. One is about the rod cutting, and the second is about the knapsack problem. Okay. So we go to the first one first. So they are about the rod cutting problem. Okay, the rod cutting problem is simple. You are given a rod with the length is x. Okay, so they are the rod, and you need to cut it into a few pieces. Okay, and okay, when we cut it, right, we want to sell it, and the price, the different length of the piece have the different prices. For example, if the length is 2 cm, right, the price is $5, for example. But if the length is 4 cm, the price only $9. Okay. So yeah, that's it. So different, different length have the different prices, and we need to have a strategy to cut so that we can maximum the revenues we can obtain. Okay. Because we had many ways to cut, and the different land had a different prices. So we need to see why the combination, or we cut, why the way we cut that we have the maximum value. Okay. So there, for example, if we have the length of 4, then you have a few ways to cut, right? You don't cut, right? You keep it, then you can sell $9. Okay. But if you cut it into 1 and 3, then you also have $9, right? 1 and 3, yeah. So you also have $9. But if you cut it into 1, 1, 2, then you only have 1, 1, 2. You only have 1, 1, 2 here. So you only have $7. But if you cut it into 1, 1, 1, right? You only have $4. But if you cut it into 2 and 2, then you have $10. This is the maximum value you can get. Okay. So for this problem, yeah, we given a length, okay, x, right? We need to find a way to cut it so that we can have the maximum value like that. Okay. So to do that, right, actually you can, very nice top-down approach, right? So you just, create the, the function. For example, cutting the Pn. P is just the, the price, the list of the price. P is just this array to keep track the prices of the different pieces. So the important thing is about the n. N is the length of the, n is the length of the rod. Okay. So very simple, right? If n equals 0, then of course you have $0, right? Okay. So a base case. And then, for example, you have the length n, right? Then of course you have a different way to cut, right? You the first cut, you can cut 1, right? Or cut 2, cut 3, cut 4, cut 5, cut until n, right? Because you have the length here. The length price here. So you have the n way to cut, right? So this one, you just do the for loop. It's just like, okay, what is the first cut? Okay, if I cut one, then what if you cut one? So what is the value you can get? Value you can get is price of the one, right? So they are B1, right? If you cut one, right? So the price of one, for example, $1 or something, right? So the price will be $1. And what the length? Because this one is n, right? So if you cut one, then it left n minus 1, right? Correct? So if I equal 1, then the length is just n minus 1. Then you just call the recursive function, right? For example, you have n minus 1. Then what is the value? Then you just sum up the value you have for B1, right? Then you have the value. If we cut at 1, then the value here, B1 plus a cut dot of B n minus 1. B is just, B is just nothing. B is just like to keep track the price references. Okay. So it's more about the n, right? If you cut 1, then the left is n minus 1. Then you just call the recursive function for n minus 1. Okay. Then the total price will be the total price of 1, right? The length 1 plus the n, the price if you continue cutting n minus 1, right? Then you do the for loop. For example, you cut 1, then you have this price. You cut 2, you have the B2 plus the cut price of n minus 2, right? B3, B4, and you find the maximum value among them. So this is the way you can use to keep the maximum value. The Q is just keeping the current maximum value. Okay, so you can initialize Q to very small number first, and you cut 1, you have 1 value. You cut 2, you compare with the current, compare with cut 1, right? Which one is the maximum value? Then you cut the maximum. Then it just Q is just a temporal maximum, right? The current maximum, and then it just keep the current maximum, and you have the new cut. You use a new way to cut. You compare with the current maximum value, and which one is higher, then you update the maximum. After you do the for loop, then you can find the maximum value on the way, right? Understand? So the Q is just like the keeping the current maximum. Okay. Then because if the length is n, we have n way to cut, right? Cut 1, cut 2. The first cut, the length of the first cut is 1, 2, 3, 4, 5 up to n, right? So then we just find the maximum value among the different way to cut. Yeah. So this is the recursive function. Okay. So for example, you have the 4, length 4, then you have 4 way to cut, right? Let me erase this. Okay. You have 4 way to cut. You cut 1, then the left is 3. You cut 2, the left is 2. You cut 3, the left is 1. And you cut 4, it means that you don't cut, right? The left is 0. Then recursive function, right? If you cut 1, then you have the 3. Then 3, you have also 3 way to cut, right? 1, 2, 3. Yeah, similarly, you can see that. Yeah, this is sum of the not in the recursive. But this one have the problem, right? You can see the problem. There are so many duplication. For example, 3 here and 3 here, right? The value of 3 here and the value of 3 here or something like 3 here, right? Right. Or if you cut for example 2, right? Then later you if you cut 2, then later you also have cut 2, then you need to refine the maximum value, right? So you can see a lot of duplication, right? Here you find the maximum value for 2, you need to do the recursive function. Later you see the maximum value for 2, you also need to call the recursive function, right? So a lot of duplication. But yeah, this one is just of course a nice way. Okay. So what is the complexity? Of course, you can see, right? For each one, you have 2 way to cut, right? Cut 2, cut 2, cut 2, right? Cut into 2 pieces. Then you have the n weight. The length here n. So the complexity will be O. 2 power n. Okay, so very huge complexity, right? And a lot of duplication, like I just mentioned, a lot of things that you need to recalculate because of recursive function. You just call the recursive function, and they need to recalculate again. So this one actually, if you have some way to store the value, right? For example, if you can find the maximum value of 3 here, 2 here, then later you face with this problem again, then you don't need to recalculate, right? So that's the idea of the dynamic programming. So this one actually we can implement the dynamic programming exactly like this. So how we do? So for example, we can do the top-down, right? Top-down memorize approach. It means that, okay, we keep an array, okay? So this is just like the value, the maximum value if the length is 1, if the length is 2, if the length is n. It's just like, keep an n, okay? Then what is the maximum value if the rod is 1, rod is 2, rod is 3? So we keep here, okay? Then of course initially we don't know, right? We don't know the maximum value, so we just initialize everything is 0. So we put 0, 0 inside, okay? Everything is 0, okay? Then you look, you remember for the recursive function, right? We have recursive function it, and this is the dynamic programming. You can see it's very similar to the recursive function, right? The only difference is 2 things here, this one and this one. You compare this one and the previous one, right? Cut rod, if you do the for loop n minus 1 and q is just a maximum, this one exactly the same, right? The only difference is they have this one. So what is the meaning for this one? So the idea is very simple. When you are checking the rod at a length n, right? Because you are having the array to store, right? You just need to check the index, the storing table. Okay. So there are table R to store the previous value. Okay. So you check whether the Rn greater than 0. Because initially you initialize everything is 0, right? If they greater than 0, it means that somehow it calculate before, right? Then you store it in the Rn. So that's why the Rn value is greater than large than 0. So if you just check, okay, if Rn bigger than 0, it means that you already calculate the maximum value for n, then you just use it. You don't call the recursive function. The idea very simple. If you already calculate the maximum value at the rod n, right? Then you just reuse it. You use the array to reuse it. You don't call the recursive function, right? So unless you don't have you didn't calculate it before, then you call the recursive function to calculate, right? But then after this one, you just assign the calculation to the Rn. It means that we record the Rn, right? It means that, okay, if you have, then you just use, you don't call the recursive. If you don't have, you call the recursive to calculate the maximum value at n. Then we remember this. Remember by you just write down the value of the maximum value. Write down the value we got into the Rn, so that later we see it again. We don't recalculate. We just use it. So very simple. You just add 3 lines, right? Here and here. Here means that if they are already calculate, then we just reuse. If not calculate, then we store it. Yeah, the idea very simple like that, right? So there are one, the dynamic programming way to do. We do the top down, okay? Because we start with n. We can also do the bottom up. Bottom up means that, okay, we have the n, right? The length of n. We need to find the maximum value of the cut, right? So we start with 0 and 1 or 2, 3, right? So we also keep the array. Then we start with 1 to n. Okay, it means that we find the value if the length is 1 first, then what is the maximum value? If the length is 2, what is maximum value? If the length is 3, what is maximum value? So J is just like with, do the bottom up, okay? And what is the I mean? I mean, if the length is J, right? If the length is J, it's just the same thing, right? How many way we can cut, right? We can have n way to cut, right? Sorry, we have a J way to cut, right? Because the length now is J, right? So we have a J way to cut. So that's why we for the value of the J, right? It's just a maximum value of the different way to cut, okay? So that's why you just a maximum value of the current one, right? Or you cut at the I, okay? So just like the previously, right, you had a J way to cut, and then you keep the maximum value. So the maximum value will be kept in the RJ. RJ also the result, okay? Yeah, correct. So it record what it had previously. Okay. So it's just like, okay, for example, you it just store it in the RJ directly, okay? And RJ also the array that we want to keep the table. So it means that okay. So when you want to cut, you had a J, right? Then you just cut 1, then you have the value of B1, right? And the Rj minus 1. But Rj minus 1, because you do the for loop from 1 to n, right? So when you calculate the Rj, you already know the Rj minus 1, right? Because you do the bottom up, you do calculate the R1 first, right? Then you calculate the R2 up to the Rj minus 1, right? You already calculate this, and now you are finding the Rj, okay, right? So the Rj is just a maximum of value of the current Rj, and then the Rj minus 1, Rj minus 2, Rj minus 3 plus the price of the cutting, okay? For example, if you cut 2, then the price here will be B2, right? B2 plus the Rj minus 2, right? Right. And you know that, okay, Rj minus 2 you already calculated before, right? So you just reuse this. Then B2 is just a price. If the length is 2, then it's just a B2. Then you compare with the current maximum. Then you do the for loop here. Then after the for loop, you can know the value of Rj, right? Rj is the maximum if the length is J. Then you store the Rj. And you continue Rj minus 1. Rj plus 1. Right? Right? And up until we stop at Rn. Okay? We stop at Rn. Then we stop. So let's say the Rn is a maximum value if the rope length is n. Okay. So that is bottom up, right? When you calculate the Rn, you already know that on the previous one already calculate, and you just use it. So that's why this one they know recursion function, right? You do the bottom up. You calculate the Rn, you all know that on the previous R0, R1, R2, R3, Rn minus 1 already calculate. And you just do the for loop in I, because you have for the Rn, right? You have the n way to cut from 1 to n. Then you just reuse on the previous value here using this one. Okay. So what is the complexity here? Complexity here because you have the 2 for loop, right? From 1 to n, also from 1 to j, also about n, right? So the complexity will be O n squared, right? So it's similar to this one. This one also the O n squared, because you do the recursive function, right? Not really a recursive function, but you call a recursive function, and every recursive function only count 1, right? Because they use the table here. To fill the table, you need n, right? And then you do the for loop from 1 to n, so this n square also. Okay. Recursive function, you call n minus 1. If they did not calculate, then call n minus 2, it did not calculate. After calling everything that you already calculate, right? Then later you don't need to recalculate. But so that's why the complexity is n times n here, because the way we do the recursive one is n times. Okay, so n times n, this is n squared. Okay, so for the top down and bottom up, yeah, both all n squared. So you can see, right, original one, if you just use the knife top down recursive without the dynamic programming, you need the 2 power n, right? But now you only need n squared. You can reduce a lot of things. Yeah. Right. So any question for this one? The truth table on the slide for the bottom up dynamic programming. So what do you mean by the truth table? Okay. So the truth table is for the bottom up, right? You calculate the R1 first, correct? So R1, it means that you only have one. R1, you only have one way to cut, right? It means that you don't do anything. You just keep the rope, right? You cut one. Cut one means that because the length is 1, right? So it means that you keep the length. So you have the value for R1, right? Right. Then you calculate the R2, okay? For example, you calculate the R2. Calculate the R2 is the length E2, then you have 2 ways to cut, right? Either you cut half, right? So you have the 1, 1, right? Or you cut 2, it means that you have the 2, okay? And there is 0, okay? So what is the value if you cut 1, 1 here? So this will be the value of 1, right? The B1, right? So there B1. Understand? And then the left is length 1, right? Length 1, you already know this is R1, right? You already calculate. So you just plus with R1, right? Correct? And if you cut 2, 0, then this is just a B2, right? Actually, this one plus with R0, right? Previously, right, you will call the recursive function for the remaining rod, right? When you cut the first cut, right, you call the recursive function for the second one. But now you don't use a recursive function, you just reuse this. Because you already know that R1 already calculate, R0 already calculate. Then you just find the maximum value here. Then you know that, okay, this is for the R2. Then you can fill in the R2. You get the maximum value, you fill in the R2. Okay. Then now you continue, you have the tree. Okay. Understand? You have the tree, right? You want to cut. Then how many ways you cut? You can cut 1, right? And the left is 2. Okay. Or you cut 2, then the left is 1. Right? Or you cut 3, it means that you cut 3 and the left is 0. Then this one you have a P1, right? The value of the P1, right? The value of if the length is 1, the value of if the length is 2, the value of the length is 3. And this one previously you need to call the recursive function, right? Right. But this one actually you have the R2, right? This one is R2. Okay. Right? So because you already calculate, you know that okay, for the length 2, we only calculate the maximum value of cut. So R2. Here R1, right? And here R0. Okay. Then you just plus with the B1 here. Okay. So there B1. Then you find the maximum values. Then you find the maximum value among 3. Then you fill in the R3. Yeah. Similarly, then you can, fill the value for Rn. Like this. For the R3, yes, for the R3, right, we have 3 ways to cut, right? We cut 1, then we have the left 2. We cut 2, we have the left 1. We cut 3. cut one, then you sell the one, then you have the left two, right? Reversely, you need to call the recursive function for two again. But now you just reuse R2. Okay. Is it confusing? I think it not really, right? Because, for example, you cut the Rj, right? We have, for example, you have the Rn, right? Then how many ways you can cut? For the first cut, right? So either you cut one, you sell one, and you have the n minus one, right? Correct? The n minus one, you need to do the recursive function, you find a way to cut, right? So it means that every time you cut one piece, you sell. For example, you have the n, the length n, right? You cut one, then you sell. You have the n minus one. But because you already store the Rn minus one, because Rn minus one is the maximum value of the cut if the length is n minus one. So you just reuse it. You don't call the recursive function, right? So similarly, right, if you have the length 2, right, the length n, right, you can cut one, right? But the first cut, you can also cut 2. Cut 2, then you have the length 2, right? You sell the length 2, okay? The B2 is the price of the length 2, okay? Yes. The B2, B3, B4 is they given, right? They're given. So the value of B here. B is the value here. They are given us, okay? So they are already given in the problem. So B1 is 1, B2 is 5, B3 is 8, okay? So this one, we are talking about the first cut, right? Sorry, the first cut, you have the n, right? The first cut is you cut one, you sell one. Then you have the rest n minus one. You need to do the recursive function, but now you don't do the recursive function. You have the array to store the reverse calculation. So you have the Rn minus one. So you just reuse Rn minus one, right? Or, okay, so there are cut one. If you cut two, the first cut is two, right? For the length is n, right? You cut two, you sell two, right? Then the rest is n minus two. N minus 2 you also have, right? You store, because when you calculate Rn, you already have calculated R1 to Rn minus 1. So Rn minus 2 you also have. So you just reuse it. You don't need to do the recursive function. Similarly, right, if the length is n, right, you cut 3, then the rest is n minus 3, Rn minus 3 you already have. So that's the idea for the dynamic programming. Okay? So understand? The dynamic programming means that you already calculate it, then you store it. You don't need to do the recursive function, right? So understand here? Because the length is n, so you have the n way to cut. So that's why is you have the for loop here. Yeah, you have many ways to cut. Yeah, and then you just find the maximum value of all the ways. Okay. And then this one is for bottom up. You calculate R1, you calculate R2, then you calculate Rn. Then when you calculate Rn, you know that on the R1, R2, Rn minus 1 already calculate and store it in the array R here. So that's why you can just reuse. Okay. Yes, the length is n. The price is the p. Okay. P1 means that the price is the price. If the length is 1, then P1 is the price of this. B2 means that if the length is 2, okay, then you can sell something. So B is this one. Yeah, this is the P I mentioned. P here. P1 is 1, B2 is 5, B3 is 8, B4 is 9. Okay. And the maximum value we keep is in the Rn. Yeah. Okay. So we start an array R here. Okay. An array to keep the maximum value. If the rod then is 1 to n. Okay. So firstly, we calculate the R1. If the rod length is 1, then we calculate the rod length. If the rod length is 2, the rod length is 3. Okay. For the R3, right, Okay, I back to R3. Okay, R3 means that you have the rod length E3, right? This is the rod length E3. Then how many ways you can cut? You have 3 ways, right? You cut one, you sell this, and the left is 2, right? Okay, this is one way to cut. Or you can cut 2, right? Cut 2. The first cut, you cut 2, and the rest is 1. Or you cut 3. It means that you keep the original one. Okay. Then you sell this one. Okay. If you cut 1, you sell this one. So this one will be B1, right? And the length left is 3 minus 1, right? Right. So this is 2. Okay. And you know that for 2, right, you have the maximum value is R2, right? You recalculate before, right? So you just reduce R2. So the total price will be B1 plus R2. Similarly, if you cut 2, you sell away this one. So this is B2. Okay. And the rest is the length is 1. So you know that, okay, you have the maximum value for 1 is R1. So the total price, the total value will be B2 plus this one. And if you cut 3, then you have the B3, right? You sell this one immediately, so you have the B3. The rest is 0, so you know that it's R0, okay? Then you just compare the 3 value. This one, and this one. Which one is maximum value? Then you know that is the maximum value for the 3, right? Then you store it in the maximum value. So the maximum value, right? Among 3. Then you store it R3. So that's the way you calculate the R3, right? So you store it R3. Then you continue calculate R4. So understand here? Yes, correct. R2, yeah, you find the R2, mean that you have 2 ways to cut, right? You cut 1, you sell 1, then you left is 1, right? The left is 1, you have the R1, right? Okay, or you cut 2, the left is 0. Cut 2, you sell the length 2, yeah, B2. Then the left is 0, then you have the R0. Okay, so that's the way for the reuse, right? Then you calculate bottom up. You calculate R1 first, calculate R2, R3, because you know that when you calculate R3, you already know R2 and R1 and R0. Then you can reuse. You can reuse R3, R2, and R0. R3, R1, and R0. Yeah, you can reuse. Previously, you need to call the recursive function, right, to calculate. But now you could just reuse. Okay. Is it clear? So, any more questions? Okay, good. So we go to another problem. It's just a knapsack. It's just like you have you have the n items. Yeah, for example, you have the 4 items here. Okay, with a different size. So S is the size, and the item also had a value. Okay, and you have a bed. Okay, your bed here with the capacity is C. C is the size. Okay, so it means that the different items have a different size. Size stored in S. S means size. Okay, and V means value. Different item have a different value, and you have one bed with a capacity is C. Then you need to choose which item you put into your bed, so that okay it fits into your bed. Okay, it means that the total size cannot be greater than C. Okay, but the value is maximum value. Okay, it means that I mean like the thief, right? They go into the house, right? You only have one bed. I mean the thief only have one bed, right? Then they need to choose the item into the house to get so that they can fit into the bed and the value is maximum, right? Then the strategy is you choose something that's small but have the most value, right? For example, you don't choose to take the TV, right? You choose to take something like diamond, gold, something, right? Small to put into the bed, but the value maximum. So that the total value maximum, but still fit into the bed. Okay, understand this problem? Right? So what is the difference between this problem and the previous problem? So the difference is for this problem, right? One item only have one. Okay. For the previous cutting, right? Actually, you can cut, for example, the size is one, you can cut many ways of one, right? But this one, you have the limitation of the item. So means that all item only have one. Okay. So there, for example, this one 4 items, you can only choose among 4 items. Okay. So that is the difference. Okay. So it's just some, I mean, some way to show that. But I mean, the way is like that. You have an item, and you have the capacity. This is the size C. Then you need to choose the item so that you can maximum the value. So the size stored in the S means the size. V means the value. VI means that the value of the item I. SI means that the size of the item I. And CAR, I mean the capacity of the bed. Okay, the bed size. Okay. So how we can choose which item we put into the bed so that the maximum value, that's the problem. Okay. So this one is just a mathematical thing. I think a bit complicated if you look at this, but I mean the idea is like that. Okay. N item you choose so that you fit into the bed with have the maximum value. Okay. So you choose to put that. Okay. If you have the infinity capacity, it means that your bed is super big, right? Then of course the easiest way you keep everything, right? You get everything, right? No need to think, right? Because your bed is like the Doraemon bed, right? You can keep everything inside, and you don't need to think. But because your bed has a limitation of the size, then you need to select it. Okay, select which item we need to put in. Okay. So actually, you can do the proof for algorithm, right? The proof for algorithm means that for each item, right, you have two choices, right? Select or not, right? For each item, right, two choice, select or not, right? Then you can, okay, for example, select, for example, 0, 0, 0 mean, for example, you have 3 items, 0, 0, 0 mean that you don't select anything. Okay, so what is the value you have? If you select the item 1, so what is the value you have? If you select item 2, what value you have, right? You can do the brute force search, right? But for each combination, you also need to check the size, right? Because you have the condition that the size, the total size you get cannot more than C, right? The capacity you have. So you need to check. Okay. But anyway, you can do the brute force search, right? Because each item you have the two choice, choose or not choose. So the total of the combination will be, if you have n item and each item you have two choice, right? Choose or not choose. The total combination will be 2 power n, right? And then after that, you just choose the maximum value with the condition is the size of the items you choose is less than C. Okay. Then you can have the best solution, right? But the complexity is 2 power n. Okay. So very huge, right? So therefore, so what is so therefore whether we can apply the dynamic programming here. Okay. So if you look at it in this carefully, right, you can see that there are a few sub-problems that are overlapping. For example, if you don't select the item 1, if you select the item 2 and 3, you calculate the V2 plus V3, right? So the value is V2 plus V3. Later, if you select 3 items, you have the value is V1 plus V2 plus V3. But of course, if you know that, okay, item 2 and 3, the total value is V2 plus V3, right? Then later, you don't need to recalculate again V2 plus V3, right? Because you know the value already. You can reuse it, right? So that's the idea for the dynamic programming here. If you already you already recalculate the value of V2 plus V3. Then later you see the V2 plus V3. You just reuse that. You don't recalculate. Okay. So how we can reuse that? So it actually, right, for the knapsack problem, right, we just need to come up with a recursive formula. So recursive formula, you have the two things you need to consider, right? The items, right? The number of the items and the size, right? So I here corresponding for the number of items you have. If, for example, if I equal 3, mean that you have 3 items to choose, 1, 2, 3, okay? I equal 10, it means that you have 10 items to choose, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I is the item, okay? And J here is the capacity, okay? So J equal 5, mean that, okay, you only have the capacity of 5, okay? So here, understand, right? I mean that the items, okay? I is items. The number of items you have, okay? This is the number of items. I is number of items, okay? And J is the capacity, okay? Okay. And this is the value V. V is the array to keep the value. Okay, V is just a value, right? For example, V is a value, and okay, value is V. Weight is just a weight. Okay, weight we start it by S. Okay, okay. S is the weight. Okay, the size. Actually, this one we should call it the size, not the weight. But anyway, because we put it like the kg, so yeah. So S is the size or the weight. V is the value. I is just a number of items. I equal 5 means that you have 5 items, 1, 2, 3, 4, 5. And J is the capacity, okay? So this one, you can apply the dynamic programming because you have the recursive function. How can you come up with this recursive function? Actually, the idea is very simple. You have, this one means that you have I items, right? And you have the capacity is J. You have I item, means that you have the item, for example, J equal 40. I equal 4, it means that you have 4 items, 1, 2, 3, 4. Okay. And your capacity maybe something like 5 or something. Capacity, right? Yeah, bad, right? Okay. So it means that you have, for example, if I equal 4, J equal, for example, 5. Okay. So you need to calculate the maximum value with the 4 items, right? And the size is the capacity you have is 5. Okay. So how you choose? Given the, I mean, this one, how you choose? Because you have 4 items, right? So you see the last one, the last item 4. You have how many choice? You have 2 choice, right? For every time you only have two choice, right? Like the recursive one. Either you get this item or you don't get it. Okay. So if you don't get this item, it means that you don't want to choose the item 4. Okay. You don't want to choose the item 4. So it means that how many items you have left? Only 3 items, right? To choose. Right? If you decide not choosing the item 4, then you only have 3 items to choose, correct? So it means that what you have, the left, you have only M4 minus 1, right? M3, right? Because you include the item 4, okay? You can use a linear programming, but the complexity may be high, right? Linear programming, yes, you can use it. I mean, you have many ways to use it. The simplex method can be used to solve this problem, okay? But now we are studying about a dynamic programming, okay? So if you choose not to use item 4, so you only have 3 items to choose, right? So the M3. And whether the size, your capacity change? No, right? So your capacity is still 5, right? If you don't choose this, so similarly, if you generalize, right? If you the item I, right? You have the I item, but if item I you don't want to use, so the number of items will reduce 1, right? So you only have the item 1 to I minus 1 left. But the capacity doesn't change. So it means that M I minus 1 change. So this is the first decision, right? The second decision is you want to get the item I. If you get the item I, so the number item still less 1, right? Right. So still like I minus 1, correct? Because you already choose it, so later you don't need to choose it, so the number of items still I minus 1, okay? But the size already changed, right? Because you choose the item I, so the size it will be minus with the xi, right? The size of the item I, correct? So the total size you have is just j minus size of I. Understand here, right? Originally you have the size, your bed is, for example, 5, okay? You have 5 kg, but you choose the item 4. Item 4 is 2 kg. So the total size you have is 5 minus 2, right? Is 3, right? Right, correct? Right? So that's why you minus the size of the items you choose, okay? So they are j minus si. But because you choose this item, so the value you have is vi, right? Correct? You choose item I, so you increase the value. So it means that you have two choices, right? Either you don't choose item I, so the maximum value is mi minus 1j, or you choose item I. You choose the item I, the value you have is I minus 1 j minus si plus vi. Understand? Right? You don't choose, you still I minus 1 item left, and the size doesn't change. If you choose it, you still have the I minus 1 items. Your capacity degree change, right? It degree to j because you choose the item I, so degree the total is si, right? The size of the I, but your value increase. You increase the value to vi. Then you have two choices, right? Choose item I or you don't choose item I. Then you just do the maximum value. Then you can have the optimal solution for MGI. So that's the recursive function you have, right? Because every step you only choose or not choose, and you just compare the two values. Which one is the bigger value? Then you choose this one, right? So simple like that. Okay. So understand here? Any question about this formula? Okay. If there's no question, then yeah, go to the actual, I mean the value. For example, if you have I equal 4, j equal 5, right? Then the things is M45. Yeah, in the lab exercise, yeah, you will implement this one. Okay. Then you can see, you can understand why, how is it going. Okay. So in the lab, you will have the chance to exercise. But the idea, you need to understand the idea, right? Because if I give the code right now, but without the ideas, you don't know how to come up with this formula for sure. Okay. So you need to understand the formula. And after you have the formula, you do the running very fast. It's just a for loop. Okay. But you need to understand the principle here, why you have this formula. Okay. Then you can see, right, if you have you calculate N45, N45 means that you have the 4 items and the size 5. So either you choose this one, you don't choose the item 4. So you have the value M345, right? Because you only have 3 items left. Right? So M35, the size doesn't change. Or you use the item I, you pick up the item 4, right? So you pick up, item 4 here. So you pick up the item 4. So you still have the 3 items left, right? So it's the M3. And the size, because you pick up the item 4, it costs you 2 kg. And the total kg you have 5. So the capacity you have left is 3, right? Right. So these are values you left, okay, M33, plus the value you get, because for item 4 have $15, so it's just a 15. Then you just compare these two, right? Then you choose a maximum value, right? So it means that when you calculate M45, you just calculate the M35 and M33 plus 15, and you find the maximum value, right? So that's exactly the dynamic programming you can do, right? Right? Because when you calculate the M45, you need to calculate M35. You need to calculate M33. So actually, if you have the M35, M33, then you don't need to recalculate, right? You just reduce, and you can know the M45. Then you keep the value of M45. So that is the idea here. So the idea for dynamic programming very simple. You just keep the 2D matrix. So there are I, so the number of items. There are J. Okay, the I is the number of items. J is the capacity. Okay, and the items here. Then you just fill in bottom up. So if you have item 1, okay, so this one mean this one mean you have the size. Okay, for example, this one, you have the capacity 1. This means that you have 1 kg, and you only have 1 item. Then what is the value? Okay, so 1 kg, you can see you have only 1 kg and only item 1 to choose. Because item 1 costs you 2 kg, so you cannot choose, right? It's so heavy, right? So you can you can put the value 0 here, right? Similarly, if you have the 2 kg, right? You have the 2 kg, but you only have 1 item, item 1. 2 kg, but only item 1. So of course you choose the item, right? Similarly, if you have the 3 kg, but only have 1 item, item 1. So of course you choose it, and you fill this table, right? Then how to fill this one? Fill this one, you just apply the recursive function, recursive formula. So M21, right? M21 equal M11, right? So equal M11. M11 you already calculate, right? Right? If you want to calculate M21, you need to calculate what? This one, right? M11, right? M11, right? But M11 you already recalculate, so you just reduce the value, so they are equal 0. Okay? Or M21, then you need to calculate M1, right? 2 minus 1 is 1. J is 1, okay? J is 1. M21, then you minus the S2, right? S2 is, the size of 2 is 1. So it means that J minus 1, right? 1 minus 1, right? Or 0, okay? Right? But assuming everything that M10 means that you have capacity 0, right? It's a 0 already, right? Okay? Yeah, just a base case. Okay? So you just compare, okay, if M11 is 0, the M10 is 0 plus the V1, plus the V1, right? Sorry, plus the V2, because I equal 2. So the left hand side will be 0 plus V2, so it will be V2, yeah, like this. And the left hand side is 0. 0, this one is V2. So the maximum value is V2. So you fill in V2 here. Okay. So similarly, you can, filling the table one by one. Oh, sorry, why I cannot choose? Yeah, then you just fill the table one by one, like this. Because they are bottom up, right? You just do the for loop, right? For I equals 0 to I equal 1 to n, j equal 1 to c. Then you can fill in this table. Yes, I equal 4 means that you have 4 items. 4 items. I equal 4 means that you have 4 items, 1 to 4. You 4 items to choose. Then you can do the for loop, and then you apply this one. Then you can fill the table. Okay. Yeah, for example, you can fill the table. Yeah, just you fill 1, 1 first, 1, 2, 1, 3, 1, 4, 1, 5. Because when you fill the ij, right, you know that on the previous, for example, you fill this one, then you know that on the previous thing already filled, then you can reuse, right? So you fill this one. Somehow you can, for example, you will calculate the 2, 3, you will reuse the 1, 2 plus something. Yeah, then you calculate this one. Okay. Actually, you don't calculate, you just do the for loop, do for loop, and then the computer calculate for you. And then eventually you will get this one value. So they are total maximum value you can get. Okay. So it means that if you have the capacity 5 and you have 4 items to choose, the total value you can get is 37. Okay, 5 kg, then you can get 37. 37, actually 37 means that you choose this one, and this one, right? The size is 2, 1, 2, 5 kg, and you get the 37. Yeah. Okay. Then you just run this one. You do the 2 for loop. I from 1 to n, j from 1 to c. Then you apply this one. Then at the end, you just pick up the last value. Okay. Then this is the total value you have. So it means that using a dynamic programming, you can find this value, the maximum capacity. Then some of you may ask, then okay, at the end you can find the maximum capacity, but how can we know which item we choose, right, to get this maximum, right? So it is very simple. Actually, everything, every step, right, for when you do the for loop, right, you find the maximum value. But actually, you remember in the C, right, if you don't reuse the built-in function, right, how you can find the maximum value? You need to calculate this one, right? Right? Then you need to calculate this one. Actually, you just compare. If this one, for example, this one is A2, right? This one bigger than this one, mean that you choose item I, right? Correct? So it means that you just compare A1 and A2. If A2 greater than A1, it means that you choose the item I, right? To get the maximum value. Then you just bring down it. Yeah. The item you choose. Okay. So when you do the lab, right, you can do this and you can figure out. Yeah, very interesting one. Okay. But at first, you need to understand why you come up with this recursive formula. Okay. So the dynamic programming, very easy. Dynamic programming is just filling the table. Okay. Dynamic programming is just filling the table. But the most difficulty is how you come up with the recursive function. This one, right, actually you need to think about that. Yeah. Think about, for example, you have the n item capacity ej, then how you do. So for n item, then you just think it recursively, right? For n item, then for every step, right? With item I, either we choose or not choose. If we choose, what the value? If we don't choose, what the value? Then choose or not, then we just compare the value. Then you know that, okay, for the item I choose or not choose. Very simple like that. Okay. So that's why we come up with this formula. Okay. Then the rest is just, the filling the table, right? Right. With the base case, some base case. For example, mi0, it means that you have capacity 0 and mi0 of course equals 0, right? Or m0 m0j means that you don't have any item to choose. That of course also 0, right? Because you don't have any item, right? Then the rest is just filling the table. Filling the table is just actually you just do the for loop. For I equal 1 to n, for j equal 1 to c, then you do the mij. Then it will automatically calculate for you. Okay. So any question? So the most difficulty is how you come up with the formula. If you have the formula, then the rest is just automatically running. You do the two for loop, then you can calculate. Okay. For the come up with the formula, then this require you some, some logic thinking, the way we recursive. For example, when we calculate, we choose 4 item, then you choose, okay. So item 4, we choose or not. Item 3, we choose or not, and we write down this formula. Okay. So any more question? So in the lab, you will actually do this. Okay. But you need to understand about the intuition behind first. The lab actually you just do a few lines, right? Do 2 for loop, then you can have the value easily. Okay. But you need to understand why you need to do the 2 for loops like that. Okay. Yeah, it's just yeah. So why the complexity? Complexity very simple, right? You loop I from 1 to n, j from 1 to c. So the complexity is just nc. Okay. Compared to reverse complexity 2 power n. Now you only the nc. Okay. Yeah. So they is a recursive formula, and they'll just create the 2D matrix to store this. Yeah. Then you just fill in. Okay. Yeah. So that's all for today. So any question about this lecture? Oh yeah, remember the deadline for the assignment 5 is tonight. So at the end of tonight, I will stop the test. Okay. For the assignment 7 and 8, like I mentioned, right, I will combine the assignment 7 and 8 together. So I will release it next week. Okay. So any more questions? For quiz, no worry that I don't test you very difficult. So I test you some, the intuition, the intuition behind. I don't ask you to come up with this formula. So even though for quiz or test, I don't ask you to come up with the formula. So no worry. Okay. So I just ask you some, some principle inside. I don't ask you to come up with the formula. Okay. The formula, it take long time to practice. Not easy. Okay. To me, right, sometimes that is the problem solving. The problem solving you need to think, because for some problem, right, I need to, even though right now, right, for some problem I need to spend like 1 day to come up with a formula. Yeah, not easy. So this one is need time to practice. So I just ask you some, principle about the lectures. Okay. For the bottom up, okay, for the rod cutting, right? What if we use J equal max of J? What do you mean by the RJ and J minus 1. Oh, I understand. It means that you replace the Ri instead of the Bi, right? Ri, yes, you can do that also. I believe you can do that also. Yep, you can do that. Yes, I believe. During the lab, you can try, but I believe you can do. Because the Ri also you cut, right? And you need to optimize, find the optimal value. Yeah, you can do that. You can test, but I believe it also work. Okay. It's just a different way we think, right? Either we think that we cut, then we sell, or we cut two parts and we find the optimal solution for two parts. Yeah, it's just the different way to think. But I think, yeah, this one also work. Okay. Okay, any more question? Let me stop the recording first. Okay, if you don't have any question, you can leave. Then see you next week.